The Semantica analytic platform, developed by Semantic Research, allows targeting analysts to integrate operational data from numerous sources to rapidly identify patterns and relationships among disparate sources of information. This enables analysts to develop a picture of the activities and associates of criminal and terrorist actors. The following fictional demonstration, developed by analysts at Praescient Analytics, demonstrates the power of the Semantica platform in the hands of skilled counterterrorism targeting analysts in a notional find, fix, finish, analyze, and disseminate targeting workflow. On June 6, 2014, security officials affiliated with Morocco's domestic intelligence agency, the DST, arrest Yusuf Basara, a known extremist suspected of plotting to bomb Café Central, a coffee house frequented by American, French, and Spanish tourists in the northern city of Tangier. As a result of his arrest, security officials obtained pocket litter and cell phone data from Basara, which analysts can exploit for intelligence purposes. On this graph, we see copies of the pocket litter, documents that were found in his person and ingested into Semantica. Additionally, we have the data that law enforcement officers were able to extract from his phone. Let's move Basara's phone over to another network view for further analysis. Now, let's dig deeper into the data that the DST obtained from Basara's phone. By editing vicinities, here we can search for desired types of entities connected by specific links and bring them into our network. Since we want to know more about Basara's terrorist network, we'll search for any people, phone calls, and text messages stored within the phone to try and develop a better picture of his associates and their communication. Now, with all of our phone data in the network view, let's reorganize things to try and make sense of this data. To begin our analysis, we'll open up the timeline to see if there are any temporal patterns to glean from our data. We can select the time frame and manually drag a slider to view temporal events in sequence. Since we're not seeing any significant temporal patterns in the data yet, let's break it down another way. Closing the timeline, let's open up the Network View filter. This allows us to sort through the various entities and relationships that appear on the network view. Additionally, it gives us a bird's eye view of the provenance or sourcing information associated with our data. Looking at the Relationships tab, we see Basara's contacts, their associated phone numbers, outbound and inbound calls, as well as text messages sent and received. Immediately, we can see that while Basara calls a number of different individuals, the vast majority of his texts are exchanged with several particular individuals. Given this information, let's move over to another tool for further analysis. Complex networks like this phone data are well suited for analysis within Semantica's social network analysis tool. Here, Semantica assesses the importance of an entity within a given network based on its connectedness within that network using key metrics. Betweenness, eigenvector, embeddedness, degree, closeness, and local clustering. Organized in descending order using the betweenness metric, we see 4 phones jump out as possessing some of the strongest connectivity within our network. Let's drag and drop them into a new network view for further analysis. By searching for people linked to these phones, we can quickly identify 3 of Basara's potential associates. Let's take a look at each of these people individually to see if there's any information about them in our system. First, it appears that our information on Khoury is fairly limited. Next, when we open up Issa, we see a statement in his provenance alluding to additional data held by the DGSE, France's external intelligence agency. Finally, we see the same statement in Awad's entity. Based on this information, we can write up a formal request for information and send it to the French to seek additional information on these 3 subjects of interest. Luckily for us, the DGSE were willing to share their information and have sent us a SAR file, shorthand for Semantica's proprietary file format, containing additional data on our subjects. Let's merge it now with the existing data in this investigation. By searching for any direct neighbors, we can view the additional information provided by our French colleagues to identify any other entities linked to these individuals. Here, we can see the names of relatives, addresses, and contact information provided by the DGSE. Additionally, we see case notes provided by the French, indicating that Awad is currently the subject of an ongoing DGSE investigation, and that Issa is working with the French as a source in that investigation. Interestingly, we do not see any additional information associated with Khoury. It appears, therefore, that Khoury is unknown both to us and the French. Given Khoury's association with 2 known extremists, he represents a significant gap in this network. We need to find out more information about him. Working in collaboration, DST and DGSE run a joint operation to identify Khoury's biographical information and his pattern of life. The data collected during this surveillance operation are contained within a separate SAR file that will now merge with the other data in our investigation. Now that we've merged the surveillance data on Khoury with the rest of our investigation, let's take a closer look. In addition to his biographical data, we see that Khoury works as a cook at the Continental Hotel in Tangier. During our surveillance activity, we tasked sources on the ground to follow Khoury for several days and report back about his movements. This information appears in our system as position reports with temporal and geospatial properties. Let's move these reports to the GIS view for further analysis. With the position reports now plotted, we can use the timeline to get a sense for Khoury's pattern of life geospatially. As we drag the slider across the timeline, we see that Khoury's movements are concentrated earlier in the morning and late at night. By sending his home and work addresses to the GIS view, we see that they do correspond to start and end points of his daily commute. Based on all of the information we were able to collect and analyze, Moroccan intelligence and law enforcement officials carried out an operation to detain Nabil Khoury, arresting him for further questioning outside his home in the early morning hours on the way to work. With our analysis work now complete, we can wrap up our findings using Semantica's report generation tool to easily capture and disseminate what we've learned about Khoury's network and his daily activities. Praescient Analytics' deep expertise, combined with the power of the Semantica analytic platform, empowers targeting analysts to rapidly integrate data from disparate sources of operational information to uncover the illicit networks of nefarious criminal and terrorist actors.